There we go. All right. All right, welcome everyone to Energy Symposium. Before I introduce our speaker, who perhaps needs no introduction, I will say what's going to happen next week. So next week is Jorge Pinon of the University of Texas here. So Jorge is going to talk to us about the geopolitics of oil in the Western Hemisphere. Jorge has a background in the oil and gas industry and spent his years in the Western Hemisphere in Latin America with oil and gas majors, I think Amoco and then BP. So he knows a lot of the insights into how things actually got done in the past, and he knows the insights and things about how things are getting done now. And I think he has a regular speaking gig on, say, CNN International or something like this, where he does like an international take on Mexico every week. I think he has a regular speaking gig now. So he's kind of a talking head as well on issues regarding energy issues in Latin America. So he is an engaging speaker, and he always has a lot of color. So that one's going to be pretty entertaining. So who we have here with us this evening here, of course, Dr. Varun Rai, who's been here since 2010 at the LBJ School of Public Affairs after making a smart choice of getting a mechanical engineering PhD degree like myself, but he was at Stanford. And then he worked there as a postdoc in sort of the energy systems and economic analysis group. So he has this, what he's going to talk to us about, this interdisciplinary research field. So he's been doing this for the last, well, I guess a decade now or something like this, right? So we're going to learn his insights. And what he's going to talk to us about today is, I guess, effectively his lecture that he gave when he won a prestigious award in the public policy arena. So what is called the David N. Kershaw Award, which is given only once every 2 years to someone under 40. You made the cut under 40? You sure? Did they stretch that? I don't know if they stretched that. Okay, he's under 40. When he got the award? No.
They were like, can you apply a few years later?
Yes. So for someone doing particularly distinctive work in the area of public policy, so this is given by the Association for Public Policy Analysis and Management. So this is a quite prestigious award that Varun has won, and because he's done this great work is why he got this award. Of course, he also recently got tenure in the LBJ School of Public Affairs for doing the good work that he does, and I guess recently just accepted to become the Associate Dean of Research at Public Affairs so that he can try to, I guess, make research more interdisciplinary on campus. So I think we have perhaps no better person on campus to try to have someone discuss how to do interdisciplinary research on campus. So I'm glad that we're here. Varun, of course, used to run this symposium. We're coming full circle now because I was the first symposium speaker and he introduced me. So now I get to introduce Varun for this. So thank you very much, Varun. Take it away.
Great. Thank you so much, Gary. This is such a pleasure to come back to the symposium. 6 years ago is when I thought about the symposium and was lucky enough to get support from across campus so we could start this forum. It is just so delightful to see that it has continued to live, grow, and attract different people from all over the campus. So it's really wonderful to be back here. What I'm going to talk today is not based on one paper or a very deep look at one of my current research projects. Instead, what I'll do is put the body of my work, or at least a portion of body of my work, through the lens of what it means for interdisciplinary research, in particular how I have approached this. So, I put in a provocative title, which is The Art of Good Science. Well, that's a very broad thing to talk about, but from my own lens, what I have learned, what works, what some of the challenges there are that people face, and how I have tried to work around them. I've been successful in some areas, been challenged in other areas, but it's just taking you through how I think this all works. A question that I get asked quite frequently, especially from students, is, so you got your all your bachelor's, master's, PhD, all in mechanical engineering, and now you're doing policy, economics, and regulation. That sounds very interesting and fascinating, but how did you do it? And the first thing I tell them is, if I was thinking rationally, believe me, I would not have done it. It was just a factor of things and interest and some people I came in contact with that made that happen. But this will kind of put again in context as to how that story progressed, how along the way I adjusted and learned a few things to make such a big transition possible from hardcore science engineering, bridging all the way to large-scale economics and policy questions. So that's kind of the spirit of this talk. It's perfectly okay if you have questions. Please stop me along the way. We can make this very, very interactive. This is not news for this audience. So these are emissions of global greenhouse gases across the world, and obviously rapidly increasing more recently, related very strongly, obviously, to rising global temperatures, climate change, global warming, right, and a whole bunch of other issues that come from that. So this is, from IPCC, and these are various scenarios also done by the IPCC in terms of to limit global temperature rises to a certain level, say 2 or 2.5 degrees, what the emissions trajectory has to be over the next century or so. So if I can use the pointer here, there are two things that I would just like to highlight. One is that across a range of different scenarios, hopefully this works, yes, that's okay. I know the trick here. So across a range of scenarios, emissions need to peak within the next decade or so. So that's number one observation, right? So this is what needs to happen if we want to limit ourselves within the 430 to 530 ppm range. So that's number one. And second, again, depending on which trajectory exactly we follow, we are in a scenario of potentially having to do negative emissions, so basically burying carbon in whatever form, right? So these are the two main things. Pointer for me.
Hit it twice.
Okay, great, thank you, awesome. So that's kind of the broad context for my work, where I also have a lot of work on the innovation side of energy, but essentially I come very heavily in terms of not only do we need a range of innovations in energy to address the problem of emissions, but then these technologies need to diffuse quickly and widely within the global energy systems. And that's kind of the overarching question of my research. And within that, I ask questions of how does the interaction of social, technological, institutional, economic, and behavioral factors impact the diffusion of energy technologies, right? And it involves research at the interface, as I'll give you more examples of energy systems, complex systems, behavioral sciences, and public policy. One thing that I'll highlight is in doing interdisciplinary research, there are a couple things that one has to keep in mind, especially dealing with these different disciplines, how they interact, how do you take the collective body of work and actually are able to move the frontier of science. That's what we aspire to do as academics and scholars. That's very important. At the same time, it's quite challenging. It's challenging enough to do it in a particular discipline, and then trying to think about the interface of multiple disciplines comes with its own bag of challenges. So I'll kind of walk you through some of those as I have encountered them in my own research. So just to give you a sense of the different things that I encounter on a very frequent basis in different parts of my research. So things like individual decision making, predictive modeling, uncertainty and risk, intellectual property, political economy. These are all the things. You pick one of my papers, and I'm dealing with multiple of these issues in most of the papers. Not all of the issues in the same paper, but certainly many of these issues together being addressed. And again, this requires a very different type of approach, as I'll point out a little bit later. So let's, to set a more common ground in terms of what I really mean by interdisciplinary research, and so that we have a common understanding. It's really scholars from two or more distinctive disciplines coming together, linking or integrating theoretical frameworks from those disciplines. So again, it is this very critical force of different ideas from different disciplines coming together, getting integrated, right? Not just, different pieces of things which are still separated, but it's really that melding of those ideas that have to come together. The methods themselves for this research are not contained within any particular discipline, but, are cross-disciplinary in many ways. And then, of course, perspectives and skills coming together again from these multiple disciplines. And that's the spirit in which I think of interdisciplinary research. It's somewhat different than different people from different backgrounds coming together and adding pieces to it. It's really how those pieces interact with each other to produce something that's an integrated, interactive version of all those ideas and methods from different disciplines. So, and I've more detailed examples of what I am really meaning by that. So before I get into this, just a few high-level observations of how, some of my own experiences and summary of how I think about what interdisciplinary research entails. So first, three main points, but first is it is not an easy thing to do. It's certainly challenging in many different ways, partly because it involves these multiple disciplines, ideas, methods, and so on. So that's difficult. It's very refreshing if you're successful, in the sense that what you learned, it's impossible, or at least very hard to just do it if you're going down a very focused disciplinary approach. So it can be very powerful in terms of what it tells you, what it tells others, and it can be a force in and of itself. This is key, I think. So let me, it's working. So the key here is to move the frontier of science while you are working with all these disciplines. Often it is hard enough, right, to be at the frontier of one discipline and move that. But here you have to look at the interactions of all these disciplines and try to move the joint interface. Again, that's how I think about my research. I like to think of other research that I interact with and learn about. And that really comes with its very special challenge, that you now have to not only be moving the frontier, but know what the different disciplines themselves entail, where they stand in terms of their cutting edge and how they interact with each other. So that's the level of commitment it involves, basically. It takes and all of this takes a lot of time and effort. This is obviously not clear. It's one has to be very committed to really seeing this way of doing research as the way they want to make their contribution. It's in many ways it's simpler, could be more productive in terms of research outputs if one goes down a narrow lane, and because of some of the challenges I noted now, it's not obvious to make a choice to be an interdisciplinary researcher. So that's the second point. And third is related to the first one, that payoffs are risky in interdisciplinary research, in the sense that things can fail, especially if you're working in teams. I have had great positive experiences. I'll show you an example later on. But in general, more than a very narrow focused project or research, interdisciplinary research tends to be riskier, right? And depending on what stage of a career an academic or a scholar is, it can have certain implications, and choices need to be made in terms of how much one emphasizes on interdisciplinary research. And I have a couple more things to say on that in terms of the research environment and the types of incentives it provides us to engage in this type of research. So those are some very high-level observations that I have made. Other people obviously have different emphasis on these elements, or they have their own elements. So this is the structure that I'll use to organize presenting to you the different strands of my research, right? So what does it take to do good science, good interdisciplinary, especially in the interdisciplinary research context? And this is all very nicely summarized. I've tried to do it using the initials of INTER, right? The first one is invariance. Whatever the research is, the most important goal in my mind is search for lasting principles. As scholars, as academics, I think it is important for us to be thinking on very deep, core, long-term problems, something fundamental, something lasting about the problems that we try to address. So this notion of invariance is quite important. I'm dealing with two different things here. Navigability, which is to do successful interdisciplinary research, one has to be open and at some level capable and interested in being able to make a move between different disciplines, learn from different disciplines, and use that. Teamwork is extremely important. I have a lot more to say on that, but it becomes especially relevant when you're doing interdisciplinary research. So how do you work with teams, how you build teams, right? How does all that come together and gets integrated into fundamental insights is very important. The environment, the broader context that we all operate in, the incentives for scholars at the individual level. How does that interact and drive choices we make in terms of where we focus? That's quite relevant. I will say something, not a whole lot. We can do take that up further in Q&A. And then finally, risk-taking. I said, this is inherently quite risky, and so one has to make choices as to there is no safe interdisciplinary research. I mean, research in general is risky because we're asking somewhat abstract questions with unknown problems, unknown answers, unstructured problems, but especially this all get amplified when you're thinking about interdisciplinary research. So with this context, let me take you a little bit deeper and give you some glimpse of the different strands of my research and how I see them speaking back to these five, my five principles of doing good interdisciplinary research. The first one is related to research quality, the invariance, the importance of the problems, right? That has to be the most important goal. This statement was put out by the Global Research Council, which is a body of the top officers of all the different countries who are related to science and engineering funding or R&D at the country level, right? And that body in this message says that research excellence is the foundation. Interdisciplinary goal, interdisciplinarity is not a goal in and of itself. And I totally appreciate that perspective. I buy into that perspective. It's a way of approaching a problem, but the end goal has to be, well, does that approach tell us something new and deep that would not be accessible otherwise, right? So that's kind of the overarching underlying emphasis on how any research and interdisciplinary research as well needs to be put in context. So now let's take each of the principles in turn. So invariance. This is a quote from, actually not a quote, but it's from a few lines from a paper by Herbert Simon, Nobel laureate in economics, who wrote that the fundamental goal of science is to find invariance. For example, conservation of mass, energy, speed of light in physics. So that's what generally, as an overarching principle, we all need to be geared towards. Then he makes the observation that in much of science, by the way, invariants are neither as general nor as invariant. Meaning, so it's hard, very, very hard to really find true invariants. And when you find them, it turns out that they're really not that invariant. There are nuances here and there. So that's the second piece. And the third one, which applies a little bit more now to my body of work, deals more with the social sciences, is especially when you're dealing with in economics and psychology and the social sciences, you have this additional aspect of the problems that you're dealing with, which is you're dealing with adaptive systems, right? So the human systems who are designing institutions and so on, and this all has a complex adaptive nature to it, and so you have to think about invariance in somewhat qualitative and more abstract fashion. So invariance, yes, but what kind of invariance? That has to be more relevant in the context of the social sciences, if one is a social scientist, right? So I think this principle of invariance is fundamentally very, very important, ties with what I was pointing to in the previous slide of research quality being the number one driver. Now, my work and how it fits into this. So one of the, as I delved into the energy system and the energy infrastructure, one thing that I observed consistently is how the infrastructure and adoption of these technologies were kind of co-located in space and time and so on, right? So here you're looking at wind turbines somewhere in Texas. You see these are different farms, but then also all kind of co-located close to each other. This is solar adoption in California. This is actually data, quite old data. Now you see even hotter spots, right? This is actually the Miller neighborhood in Austin. These are actual homes. You see a very, very heavy adoption of solar within a very tight geographical area. This is electric charging in city of Houston, where the same people taking similar routes and charging at similar charging points, right? So there is this very general pattern of co-adoption, co-location, this structure that I have observed and others have observed for that matter in how energy infrastructure gets adopted, gets installed, and also used, right? And so one of the things that I'm very interested in studying is what social, economic, and technological factors lead to the emergence of these types of patterns, spatiotemporal patterns, in particular bringing in the social and economic aspects, right? So how does individual level decisions, how do they add up, how do they interact to give you these population level emergent patterns? And that's a problem. I'm not the first one to ask this. People have been trying to study this for the last several decades. But when you think about the social and economic forces of it, it's still quite an open question as to really how this all happens. How do theories of behavior at the individual level add up to the macroeconomic observations and theories in macroeconomics? What's that? How do you bridge that gap? And so a lot of my work is within this rubric of understanding emergence in energy systems. One of the examples of that work is for the last few years I've been building an agent-based modeling framework in my group to study at the household level adoption of solar system and electric vehicles. And what we do here is, this is household level modeling. So talk very specifically within the city of Austin, every single household, their relevant attributes, including social aspects and economic aspects, income, education. Couple that with the physical infrastructure, so tree shade, roof structure. Bring all of that data in. We also do a lot of behavioral data collection. So we do population-wide surveys. So couple the socio-demographic, the behavioral, and the physical space data together, feed them into a range of different sub-modules of modeling, so econometric analysis, GIS, that all feeds into this giant agent-based modeling framework to then help identify adoption patterns, all right, as to how adoption is happening over time. The key thing to keep in mind is there are two ways to approach this. One is looking at individuals separately, so each household and what their decision is going to be. But this is different in the sense that not only we focus, the unit of analysis is the household, but it's also how decisions of others is impacting the decision of a particular household. So the entire city, every household potentially interacting and influencing each other's behavior. So this is a coupled evolution of adoption decision at the population scale over time. It's quite interesting, involves several different pieces to come together. So we have built that model. We had actually, through several partnerships, especially with the city and Austin Energy, we were able to build the model, train the model, and then we used it for predictive modeling to see what the adoption trends might be within Austin over the next 25 years. And this is just one of those scenarios, an optimistic scenario in the sense, optimistic in the sense of solar prices and so on and so forth. We did a range of scenarios which we then fed into Austin Energy, and they used it for their planning purposes and so on. But one of the things we observed is, not just for this scenario, but in a range of scenarios, there were pockets. So given no major changes in the types of business models that were happening in Austin, there were many different other pockets that are emerging that were not there today. And pockets of adoption of solar have implications for the distribution infrastructure. So maybe right now, so this is driven by social and economic and physical factors, but the distribution infrastructure itself may not be there. So entities like Austin Energy can then take this and feed this into distribution infrastructure planning and see what needs to be done, or they might decide, well, we don't want to be putting this type of infrastructure there, so can we adjust that using certain type of incentive, which is also kinds of thing that we can ask and answer through this type of framework, which is if you change the incentive by geography or by social strata or by infrastructure assignment, how does it change the structure of the adoption and the implication for infrastructure? So this is one of those examples of studying emergence in socio-technical systems. The second point on navigability. This one is openness towards ideas from different disciplines, interacting with different disciplines, genuinely being interested, right? Oftentimes, and I've been sometimes guilty myself, is having this notion that, that is not right, that is not the way things work, this is the way things work, right? There's this tendency, and that is very hurtful for interdisciplinary research. At the very least, there has to be this openness to hear, get things, and then try to weave it in and make sense of it. And maybe still, it's okay to discard and not use it in certain pieces, but there has to be that openness. And this concept of openness and information actually resurfaces in my last point as well in a very different context. But it's super, super important. I can't overemphasize this point. This was a paper talking about interdisciplinary research in Nature, where the authors lay out a description of how they think people who end up becoming successful interdisciplinary research, what their progression is. So essentially, researchers, so this is the time, x-axis is time, and this is kind of behavior. Y-axis is how people behave. So researchers who are new to working with people from other disciplines oscillate between asserting their primacy, so dominating the conversation, to hanging back, which is whatever, keep talking, I'm shut off. But over time, with more and more of these interactions, they come to grips and they find a balancing point where they are able to engage productively, but then also kind of learn and integrate the lessons. This all has implications for how we think of teaching and research on campus. I was very fortunate during my grad studies to be exposed to a lot of different research ideas, a lot of different groups and disciplines. Some of those choices I was advised to make, some of those choices I made randomly. So for example, taking a course in political economy of energy in Asia, which that one course changed the entire course of my career. But these are exactly the types of things that expose you to different environments, different ideas, people, and disciplines, and so on, which, if done with enough frequency and density, they certainly help nurture this interdisciplinary approach that is quite important. So within this, I'll give you another example of some of my work on policy-induced localized innovation. So the idea here, the high-level observation here is that look globally, there are a range of different incentive policies at the federal, state, local levels to incentivize adoption of different types of technology, in particular low-carbon technologies. So for example, or low-emissions technologies more broadly. So electric vehicles, solar, storage increasingly, and whatnot. If you move to developing areas, just a much broader set of issues to deal with there. So there are these range of policies to incentivize this. An inherent assumption, especially when you think about state-level policy or local policy, is that these policies will encourage and incentivize local innovation, which will feed into the local economy. So policymakers, certainly, at least that's part of the rationalization for putting these policies out, or certainly in the rhetoric of it. And so one question, and this has occupied researchers in economics of innovation, a lot of including economists, geographers, and so on, as to really how much of this happens, right? So there are these policies, but really how much of it does really feed back into local innovation and the local economy, and so on. So to study that question, you have to have a strategy in terms of research, your data and methods. You have to have a strategy that links that policy very closely to the innovation happening within those jurisdictional limits and tie that back to the economy, right? And conventionally, the way this is done is, one of the main ways it is done is by looking at patent data, where the patents are being filed, where those firms are located, what their affiliations are, and so on and so forth. One issue is that patent data is organized into technology categories and subcategories, and these are broad technologies. So there is no category that says solar or wind. Nonetheless, when you look at the policies, they are very, very product or technology specific. So that's a challenge. How do you do the mapping from the categorization or codes for the patents onto very specific markets and product spaces? Because that's what is needed to address the question of this economics of the geography of innovation, right? Tying of local policy to local innovation and local economics. So it requires a different approach than the approach that has been predominant. So I got very interested in this question. I think this was 2013 or so. Got super interested, read a lot, thought a lot, and then eventually, it occurred to me that there has to be something in the language of the patents, in the description of the patents, that has to tell you about what technology it is. It's an obvious observation, but of course you can do this. You can do the mapping when you're going manually through all of the patents. But my hunch was, well, you ought to be able to learn this automatically. You ought to be able to identify patterns within the patents, and for that matter, a large collection of patents automatically. So one late night, I frantically type up all my ideas as to, I think, one has to be, ought to be able to learn this, and, send that to a colleague of mine in EC here at UT. And I got back a reply saying, yes, we have been doing this for the last 15 years in our discipline. Let's talk. So that's how it started. I got introduced to the concept of natural language processing or topic modeling. So let me tell you roughly what it is, and then I'll tell you what we have done with natural language processing. So essentially, the idea is that if you're given a corpus of documents, so let's say 1 million patents or 1 billion news stories on the web over the last 20 years, right? You're given a corpus of documents. The idea is that all of that can be summarized into what are known as topics, right? So every document is made out of certain topics, and each topic is a coherent set of ideas. So for example, gene, DNA, genetic. That's all, you get the idea of, it's all related set of different words forming a topic. Likewise, if you move to a different topic, it's brain, neurons, and nerves. So, it's certainly different from this, but it's all inherently linked to each other within a topic. And so the idea here is that each document is composed of certain fraction of each of these different topics, right? So, this is a paper, and you see that certain parts of it are related to certain topics. So all the pink portions are related to this here, the yellow portions are related to this topic, and so on. So essentially, again, the idea is each document is drawing from with certain probability from each of these different topics, right? And then that distribution of topics is different for the different documents, right? So one document draws 10% from this topic, other document will probably draw 50% from this topic. And each topic itself is a collection of words which occur in that topic with a certain frequency, right? But the topics themselves are summarizing a high-level, coherent idea, okay? So the question then is, if I can move this forward, is you don't have the topics. right? All you have is the documents. But if you could have the topics, then that's kind of the summary of the knowledge content of the documents, right? The topics are attached to different ideas and different knowledge elements. And the way certain documents are drawing from those topics is telling you what's the knowledge composition of the documents, right? So if you could have the topics, that would be great, because that allows then you to tie what type of ideas and knowledge is being talked about in these documents. So, but what you have is just the documents. And so the modeling task then is, given the documents, you have to find out the probability of the topics and the assignments and the proportions. So what the topics are, you have to identify the topics. You have to identify the assignments, so the words within each topics, and also the proportions, which is how each of these documents are drawing from each of these different patterns. So it's a very coupled optimization problem given these documents. All right. So, but there have been extreme advances made in this field just in the last 10 years or so. It still remains a very, very active area. But it's amazing how just in the last few years the use of these types of technologies have just proliferated all across in many, many disciplines. So we used ideas from topic modeling to look again at innovations that were happening in the solar arena, but in particular in balance of systems of solar. So this is all the non-panel stuff. So all the wiring and the inverters and other gear, which is not the panel itself. And what we were looking, just to remind you of the problem we were trying to address, it was tying local policy to local innovation. But before you can make that tie, you have to be able to identify if certain patterns are related to your area of technology or market that you're interested in. And so we use natural language processing to query a large pattern data set and then automatically categorize them into different parts of the solar balance of systems. And that's the most critical step one in terms of allowing you to make this connection between local policies and local policy, local innovation tied to a very specific technology or market. So what you're seeing here on the right-hand side are, these are two different metrics that we calculated for every single patent. But if you draw the patterns according to this naturally separate into these groups, which are colored by different colors, and each color is a specific balance of system components. So like inverter or racking and mounting or monitoring, site assessment, and things like that. These are, so the powerful thing here is not only are you able to identify high-level subcategories like balance of system, but you're able to go much further below and identify even much more specific areas of technologies. All right, so even within balance of system, these are sub-technology categories, and this is an automated algorithm. So you give me a new pattern. So once we have built this model, essentially it's a new pattern gets filed. We feed this in the model, and even without looking at it at all, it just tells you which category that new pattern belongs to, right? And so that kind of gives you a sense of how the market is evolving given certain policy changes. The other thing which I'll just mention to you, we can talk about it, is there are certain areas. So look at the center of the green black area. You see a lot of black and green dots together. That was a major source of misclassification that we were doing. So about 10% of this was, our accuracy was about 87% or so. We were consistently, no matter what we tried, we were consistently misclassifying 10 to 13% of it. And that is because the inverter and site assessment categories of balance of system innovations were merging. So this was it was an underlying current that was happening in the industry, because there were synergies that were happening at the technology level. And so it was being impossible, but that was for a good reason, because it is very hard. Within the same patent, you are fundamentally seeing ideas from inverters and assessments coming and merging together. So this, we in the paper, we identified this potentially as a method of studying technological convergence also. Dave, you have a question?
Yeah. Is this rooftop PV integrated, or is this also including utility scale?
No, this is great question. I just chose to leave away that detail. This is rooftop PV, including, of course, both residential as well as commercial, but mostly rooftop, not utility scale. yes, it might look differently for utility scale. And the thing was this, tying to local. So for example, what does Austin Energy's or City of Austin's rebates for solar do for, installations, not just installations in Austin, but then how much are firms in Austin filing for these patents and innovating and potentially feeding back into the economy. So it was that link, and so certainly rooftop PV has a much more local tie, so it's much more amenable to this type of analysis.
Do you have time to go further into why those two trends were converging?
Yes, we can take that up in Q&A. Great. All right, teamwork. This is Chanakya, one of the most profound, highly regarded teachers, thinkers, philosophers, economists, administrator, royal advisor from around 300 BC in India. His thoughts still pervade a lot of the thinking. Again, really profound observer. This is one of the things he said. I'm thankful to those who left me because they taught me I can do it alone. He was obviously not talking about interdisciplinary research. It does not apply. That idea does not apply. You have to work with others. It just is necessary, but also very, very helpful in at least these three ways that I've encountered. As I said before, these are complex problems that involve interaction of the cutting edge of multiple disciplines. It's hard enough to keep pace with one discipline. If you really want to be at the frontier of multiple places, you have to be interacting with folks from different disciplines, right? So these problems, especially if you're tackling the invariant types of problems, they're quite complex, and so you do have to interact with folks from other disciplines. You can also leverage disciplinary backgrounds. You may not be strong enough. So I certainly don't claim that I'm the expert in that and this and this and that. No, but I have to be really, really good at that, and to the extent there are deficiencies in particular projects and so on, I have to leverage other people's strength to make sure that I'm still able to address the very important question of invariance and research quality. That comes number one. The other thing, which I think is a little bit underappreciated, point number 3, is something very powerful I discovered for myself recently, is working in teams, especially when the team members are quite committed, really enhances the outreach of the work. It very quickly is able to penetrate a lot broader, much broader audience than your any average work would do, right? If something is really path breaking, it would make its way out anyway. But for an average work, I think average piece of your work, not average in terms of quality, but an average piece of research output, teamwork really has this very powerful impact of enhancing the outreach quite a bit. So one example here is I have been part of this DOE-funded Academic Partners Program, which is coordinated by LBNL. Other members include NREL, myself and my research group from UT Austin, Wisconsin-Madison, Greg Nemeth, who has spoken here at the symposium before, Ken Gillingham from Yale. In terms of our backgrounds, it covers a range of disciplines, including systems modeling, economics policy, market design, energy systems, of course. And we ask a very specific question. What technological, institutional, social market forces drive cost reductions in solar? It's a very specific question. That's all we study within this partnership. All right, and that focus keeps us all anchored and working together, excited, but then it's also a very, very policy relevant question, right? We know what we produce is going to be very relevant for policy making, but also market participants keep a close eye out on this. These are just some examples of what we have produced. So far, I think we have produced about 10, 15 reports and studies and papers. Each year, we publish 2 to 3 of these reports. Most of them get published in peer-reviewed journals also, but they first come out as LBNL reports. And I'm just going to walk you through, give you a high-level idea of one of those works that I did with my PhD student, who is now an assistant professor in China. It looked at this question of pass-through. So when A subsidy scheme is put in place, when an incentive scheme is put in place, how much of those incentives do really make their way out to the intended receivers? So this example is from California Solar Initiative, which is by far the largest state-level solar program, which the target was 2 gigawatts of new solar between a decade, about $2 billion in funding, including all the three major private utilities in California. So fairly big, quite radical, at least when it started, right? And they achieved all their goals by 2013, 3 years ahead of the schedule and so on. The question that we ask in this research is, how much of that money really made it out to the adopters of solar, right? Or how much of it was perhaps held onto by folks who are in the middle, the installers, for example. Right? And this is a question known technically as subsidy pass-through, and this surfaces in exchange rates, in tax, so forth. You can also ask if there is a tax on soda, how much of that tax really you have to bear as a customer versus how much the industry changes its pricing strategy and so on. This is a very complex problem, requires a great attention to detail of the nature of supply and demand. It might sound simple, but I discovered for myself that it was quite challenging and intricate, especially if you really wanted to do a very robust job, right, of really identifying. So the point here is you have to have a very causal mechanism to say, well, this is how much is passing on, and this is how much is remaining in the middle zone, not making its way out. So in terms of a design, the California Solar Initiative looks like this, which is it's a trigger mechanism. So there are different steps. So the incentive step level 2, 3, 4, 5. At each step, there's a certain rebate, and after certain megawatts are installed within that step, so let's say 20 megawatts are installed, then the rebate automatically goes down by a certain level. So that's the rebate is the green step curve. It goes down as more and more installation happens, and this is all pre-decided. Even before the program started, this was all, everybody knew exactly what was going to happen and so on. And the net price that a customer faces is supposed to be price minus rebate, right? Supposed to be. So there's a market price and there's a state-provided rebate. So ideally, the customer should be facing the market price minus the rebate. The question is really, that is what the net price that the customer is facing? And you have to tease that out from data, and we had California-wide household-level installation data for every single system that was installed. So how do you design research to do this? And so we used the method of regression discontinuity, which is looking for shocks in pricing. All right, so essentially we looked at all the three different utilities and installations in those utilities and tried to identify areas. So if you look at the middle bar, SCE, and if you look at the green and the blue, that's a rebate step change. So incentives went, let's say, from 50 cents per watt to 25 cents per watt. Okay, and that was an instantaneous change overnight in rebates, and that's a shock in the system, and you can use that type of shock to see what was happening in terms of pricing behavior right before the shock, right after the shock. So this is more in the nature of experimental design, right? But it's easier said than done. There are just so many other things one has to keep in mind, and that's where there is advantage in physical experiments in the sciences, where you can control the environment a lot. Here, this is all happenstance data. This is what happened, and then you have to work a lot harder to make sure that other things that could have changed, how well are you able to control for them? If things were changing too much and you don't know what, this design would not work, and so the estimates that you'll come out with will be quite uncertain and potentially biased and inaccurate, right? So there's a lot of intricate analysis that has to go into. So we did both time discontinuity, so within the same utility when rebates were changing overnight, and that's a nice shock. But then we also did geographic discontinuity. So at the borders of two utilities, what's happening on this side of the border and what's happening on that side of the border. right? So it's a geographical discontinuity. Also provides this experimental opportunity. So we were able to identify those types of opportunities in the data and then used the analysis to essentially come out with this conclusion that at least for the incentives that were being provided by the California Solar Initiative, we were finding near complete pass-through. So most of those incentives were actually making it out to the customers, right? So, and we are pretty confident about that because in this paper we do regression discontinuity, time, and geographic, but there's another paper we use a totally different method, arrive at very similar results. This is not without controversy. There are other papers that have found as low as 20% rebates, right? So and so when you write these papers, you have to tie back and say why they're finding that, and potentially in a very nice way why they're wrong and all of that, right? But we are fairly confident. But it's only part of the question. Is this true for the federal incentives, which are actually much more significant, 30% of the installed costs, right? So that's a different question. It requires a different type of data and different type of design. Anyway, so this was on teamwork, and this would absolutely not be possible, doing this type of work, if it was not with this team helping us parse this question cleverly. The point on environmental, in the interest of time, let me just skip over this. We can take this up in Q&A. But essentially, the incentives we have as individual researchers. So, how we conduct research in departments, what the expectations are, especially for junior faculty, how does that all play into what types of problems we address and so on. It does pose challenges for interdisciplinary research. What about the funding? If you do that research, where do you publish? Are there good journals? Everything is progressing in the right direction, but there's a long way to really, for the environmental incentives to be in place to really make this a no-brainer. All right, so we can take that up in Q&A. But one final thing that I do want to emphasize is risk-taking. If some of you have watched the TV series Madam Secretary, I believe it's on Netflix. It's a great, I like this quote very much. So Thomas Aquinas said that if the highest aim of a captain were to preserve his ship, he would leave it in the port forever, right? And essentially the idea is that you got to take risks. If you want to do good things, if you want to do adventure and contribute and find out and innovate, you have to leave the port, right? And I think I have found that to be very important in doing interdisciplinary research. Let me share with you in just a couple minutes, a project that we started a couple years ago, actually 3 years ago, have now been able to publish 3 very solid studies out of it. But for a long time, for about 2 years, I had a feeling that this was all going to fail. I kept thinking that, man, I've invested so much time, so much money, hired a postdoc, not going to happen. This required actual intervention, field experiment. So we had done all those modeling and, data analysis that was telling us that, there was informational gap and people are not adopting as much they should adopt because they're holding on to perceptions of what the cost of certain technologies are from 10 years, right? So we could know that. We could see that in the data. The question is, well, do you stop there or you try to see how you can move the boundary in terms of actual behavior of the people? And so, there's this pulled me into very deep behavioral psychology literature, which I had no idea about. So this goes back to this openness to different disciplines and just, being ready to learn and dive in. Very fascinating stuff, and I had no idea, but now I have good traction in what this is all about. But there are a whole range of things happening. So, for example, if you have a negative perception about something, no matter how much information I feed you, saying, hey, you pay attention to this is relevant, you're like, shut up. I don't care. I'm not interested. So that's known as the ostrich effect. It is known, it is studied, anchoring. Your decisions later on are based on what you have been exposed to before, the information you had before. It's not as if you're neutral. And this all ties back to individual decision making and biases, rational choice theory, and so on. I'll skip over all of that, but essentially what we did is ask this question: do games have greater impact than traditional forms of information delivery? So a lot of the times you find a flyer in your mailbox or an email in your email box giving you certain information, right? And that we call the passive information delivery about new technologies or new subsidies or things that you should be doing which would potentially be good for you. What if the same information was provided in more interactive, gamified fashion, right? Is that going to be more successful in changing behavior and changing perceptions and antecedents of behavior for that matter, and by how much for that matter? And does the frequency, so if I give you the same email, information in the email in 2 emails, or if I send you 2 different flyers, does it matter, right? The frequency and the information overload per communication. And so we designed this game that people actually played. So these are actual people, actual customers out there. And we did randomized control experiments. So this is all done experimentally, where people were playing this game on their mobile phones. And the way this works is this was a 2-week game. People were answering 30 questions over the 2 weeks. Each question takes about a minute. You get a ping to play the question. You can play it then or later. You get a clue. You get the question with 4 choices. You answer it. If you're right or wrong, you get an instant feedback, and then you get a little bit of an insight. So this is a trivia-style game, fairly simple, and it has this nice interactive effects. But we did the design mindful of other confounding factors. If you make the thing too complex, then you have to deal with what really is impacting the results. And along the way, we were measuring, before the games and after the game, we were measuring changes in behavioral antecedents. So your perception, your attitude of different things, your perception of the control you have over a decision. So again, basing off of behavioral psychology theory. And what we found is games do have a significant impact on antecedents of behavior. And then more frequent pieces of information have a higher impact on antecedents of behavior. That doesn't mean that if I keep shooting 100 different random pieces, unconnected pieces of information to you via email, that's more effective. No, but within a coherent system of information delivery. So for example, within the gamified system, it was showing up as having consistently significant impacts. And then also using the same thing, we were able to address some of those biases. So for example, the anchoring bias, the ostrich effect, and so on, we were able to see significant movements in people's perceptions and antecedents in those arenas. So I think that's all I have to say. I'll just remind you of these 5 principles I have found very useful: invariance, navigability, teamwork, environment, and risk-taking. And we have some time, not a whole lot, but some time for Q&A. Thank you.
So, first and foremost, thanks for the talk. You personally went through your education purely mechanical engineering, and now it appears that there are more interdisciplinary programs like Carnegie Mellon's EPP or MIT's Social Engineering Systems program. So I'm wondering, this new age of students that are going through these interdisciplinary programs aren't necessarily getting the specialized focus that one might get in an engineering program per se. How do you think that's going to change the future landscape of interdisciplinary research?
Yeah, that's a very, very good question, which is also a challenge. So these programs exist, and I'm not specifically speaking about any of these programs, but in general, it's a challenge in designing these programs, right? This balance of depth versus breadth, right? That's an ongoing thing. It turns out, what I have observed for myself, but some of my friends who are going through these programs at Stanford, we had a program very similar to the ones that you're alluding to. At some point, smart researchers who are being advised by smart people, they do identify that sliver of depth. It just emerges out. The only thing is that it will integrate other pieces, but that depth naturally emerges out of how the question gets defined. So certainly at the level of studies, there's this iterative process of discovery that takes you down a certain road, gives you your depth in that area. The nice thing being that, mindful of and integrating other pieces of area. In terms of how this all might change, we are still really in many ways at very early stages of, so there are some programs, but there are not a whole lot of these programs, partly because of these challenges. But this is where the environment also becomes important, right? If you train people in that way, so certain schools can do it, right? Just very progressive, forward-looking thinking, define the frontier of academic boundaries. But then if you produce and train students that way, where will they go? Which academic programs can they teach in and do research in? How will they get hired or not hired, right? So these are the broader questions that are very much relevant today. So this will take quite some time in terms of really how it all emerges. But in terms of the recognition that this is important, because the types of problems we're dealing in, energy and health and education, they are inherently complex and involve many different fields. So there is that recognition, and that will take its time to make it through. Question? There is a question here.
Can I have a follow-up question about your topic modeling?
Yes, please.
Thanks. It was related to this broader topic, though, of interdisciplinarity. I wondered if there was more to the story, maybe, because what I understood was that the topic modeling was sort of a means to an end, to be able to measure quickly this local patenting effort. Was there another kind of follow-up project where you then tried to trace the economic impact of sort of patterns of particular kinds of patenting?
Yes, absolutely. So we have, after this, we had two papers. Two papers. One looking at how local policies at the state level are impacting innovation at the state level. So we use this as the tool to organize the data, but then so that was an econometric modeling where your dependent variable, what you're trying to explain, is the innovative output at the state level, and the independent variable is state level, strength of the state level policy in terms of actual money provided or installed systems, all right? And we were seeing very significant impacts. So that we did in the US. We have done a very similar work in China, finding very similar results, and now we are working on Germany and Japan. So yes, we have taken this forward. You're absolutely right that this was the platform that allowed us then to ask the real question, which is what really is this link between policy and innovation? Yeah, there's a question there.
So your talk mentioned sort of interdisciplinary problem solving, but when it comes to interdisciplinary solution adoption, do you see any different barriers to adoption there?
And when you say solution adoption?
So for example, you had mentioned the pockets of solar adoption in Austin, and so how that kind of fed back into Austin Energy and how they were planning the distribution. So if you identify these multifaceted reasons for a problem, how do you convince the key players that they need to work together to solve the problem?
Great question, because firms and utilities and analysts, they have their own ways of addressing these problems. And so what's the additional value? So part of behind all of this is then doing models where we said, well, let's leave out the social forces of interaction and see how accurate we are in prediction. It turns out, you're good, but you miss most of the spatial trends. You get the spatial trends of co-location only, especially in solar, only when you bring in the social interaction. So my neighbor adopting solar actually impacting my probability of adoption. That's absolutely critical to get the spatial patterns right. But me just telling you're just so right, me just telling this to a potential adopter of my technology is not going to help. So we had to build very systematic scenarios to show really why this model is better and why, what are the elements that are making it better. So in that you have to, absolutely right. In terms of diffusing this, you have to break it into pieces and be able to compare to the status quo. There's a question.
This is related to the first question, which I thought was outstanding, and maybe you answered it, but I've got a little bit of a different angle on it. In multidisciplinary programs,
it would seem to me that you have a choice of essentially assembling the pieces that forms, you take this course, you take that course, you take that course, or actually the pedagogy, which would be entirely different, which is teaching each course in an interdisciplinary fashion. And my question to you is, how would you comment on that? What experience or what observations have you had of people who have done this or tried to do it?
It's a very insightful question. Tells me that you have thought about these issues yourself quite deeply. The latter one, I think it's a really good way to think about it, which is the same courses. The former org is easier to understand. You have different courses, and you pick from that, and you create your own portfolio, assuming there is that flexibility in the program. The latter one is really, I think, where the power is, much of it unexplored, because the requirement is then that the individual faculty will have that capability to bring those elements into a successful course. It is very challenging. I'll tell you a course that I'm teaching right now. It's Social Information and Innovation Networks. Essentially, a course I'm teaching in the policy and social sciences circles about networks, right? On all kinds of networks, a lot about social networks, but then also information networks, pattern networks, knowledge networks, infrastructure, and so on. It brings in ideas from sociology, psychology, computer science, physics, and so on. It is, and I know this reasonably well. I do research, but it is just, even then, it is just quite challenging to carry graduate students from across different disciplines together. So I think that would be just ideal, not ending, but the beginning of really making a huge impact in interdisciplinary teaching and training. But getting there, I just don't think we have the pieces right now. And that ties back to the environment, right? As individual researchers, what's the incentive, right? And we have this, for very good reasons, the way things are structured, we have this incentive structure that forces us to go very deep in certain disciplines, which has this fallout impact on how you can structure good interdisciplinary research. But I think very insightful point, something that has given me more thought to think about. There is a question there.
That was very interesting, Varun. I thank you. And I want to just introduce a slightly different angle. I'm not sure if I'm going to be able to express this well, but I think maybe I'd mentioned to you when we met first, I went through an interdisciplinary energy and resources program 35, 40 years ago. And then I left academia. I was just in there for that program. And so a related but different question, because what you're focused on is within academia and getting the researchers to work together. And the way I was looking at it, because of my own inclinations, was if I wanted to be satisfied and feel well-rounded when I went out and got a job, would that program do me good? In fact, I remember I went to a reunion of my program about 2 years ago, and John Holden, who had been the head of it, had become the head of the Office of Science and Technology Policy at the White House. And he said when he was first trying to get the program in at Berkeley, the question was always, but these people won't be able to get jobs because there's not enough depth in any one place. And he would say, but that may be just an academic way of thinking about it. It's very important if they're going to stay in academia. But the other question is, he says, they're all going to be able to get jobs, but they're going to have a different way of looking at things, and they'll go out there and they'll do very interesting things. Yeah. And he would make the point that the history of that particular graduate program was that, or the results was that people went out and did very interesting things in a whole bunch of different fields. So that's a different sort of question than maybe what's the effect within academia, right?
Yeah, and that all relates to this question of training, and I made this comment of you train these people, and are they able to get jobs or not? So there are two related aspects here. One is certainly it has to be very well thought through, not just doing an interdisciplinary program because it's exciting and people are interested and they might just join, or there's a wave of doing it. But certainly there's an onus on curriculum designers and program designers to really think it through. So that's one piece. The good news part of this is, especially not within the academia, but in the industry side, The industry is a lot more focused on problem solving. They don't care if the answer comes from this discipline, that discipline, or a combination of the discipline. So they are perfectly okay. I had experiences when I was a grad student where, especially when I was a postdoc, with my very hardcore science engineering background and the new skills I was picking up in economics and policy, companies were, really getting very excited about interacting with me, and I was very, I would say, engaging in interacting with them and thinking through different perspective of their problem. So they are way more receptive if, the program is good, the training is good, if they have these, different pieces, the students, I mean, they have the different pieces. I think the receptiveness from the industry will be good. But again, there has to be very well thought designing of that curriculum. Awesome. Thank you.